Okay, so now let's do a couple of examples on exercises on these BJPs. So first of all, as a review, and by the way, if I have not mentioned, I'm using a book. Basically, I'm using this book as a reference, which is called Complete Electronics Self-Teaching Guide with Projects. It's a very good book. I find it very useful. It's written by Earl Boysen and Harry Kybert, if I'm pronouncing their names right. And the ISBN is this. It's supposed to be a very old book, probably 2012. So 978 ISBN is 978-118 21732 732-0, and the name of the book is called Complete Electronics Self-Teaching Guide with projects. So basically this book is full of useful information, and of course you need to have some equipment as well to do some projects here as well. But of course, if you don't have if you don't care about the equipment, of course it doesn't make much sense to read this book, because anybody who reads and wants to understand this book wants to do something with electronics. So of course, whenever you want to do something in electronics, you have to get yourself simple, for example, power supply, multimeters and oscilloscopes, things like that. So it is basically a book that I have found makes a lot of sense. Usually you cannot find there are probably many types of electronics books that you can find on the internet. You can buy in bookstores and things like that, but whichever one you choose, and I did a little bit of research and I bought 4 of them. This I would say is probably the only book that can actually be used in order to learn something. So other books have all kinds of, they get you into trouble. So now, so this is the book that you can get. Now, if you want to draw the symbols for an NPN and PNP bipolar transistors and label the terminals of each. So basically a transistor, as we discussed before, is just basically 2 diodes put back to back, meaning that and a diode is basically something like this. A silicon diode, for example, would be basically a cathode, and basically then you have an anode, and then you have this is the cathode of the diode, this is the anode of the diode, and this arrow basically points in the direction of current flow, and by that I mean basically conventional current flow. And so basically the other way, going in this direction, this would be This would be the direction of electron flow, right? So, and then basically, you know that a diode basically is conducting this way, meaning that if you have a power supply, this is positive and this is negative, you connect the positive to the anode, and the cathode is connected, for example, through a resistor to the cathode, and then now basically your diode is conducting and current is going through the circuit. And so this is called a forward biased diode, and there is a 0.7 volt voltage drop across this PN junction, and this is your power supply. On the other hand, if you, no, I don't really, but we will look that up. On the other hand, if you have a diode that is connected to the power supply this way, meaning that this is positive, and suppose that I connect the positive to the cathode, and then the anode through a resistor, for example, goes to negative of the power supply, then basically this over here, you have no current going through your circuit because your diode is reverse biased. It's reverse biased, and so there is no current going through the circuit. And the whole power supply, of course, would be available at the terminals of the diode. So this is how you forward bias a diode. This is how you reverse bias a diode. In different situations, you have to do any one of these two. Any one of these two. And now basically what's important here is that an NPN transistor is basically so this is the cathode of your diode, and suppose that you have this diode over here, and then another diode like this, and then again the cathode of the diode. So the anodes are connected to one another. And so if you basically put these diodes back to back in this manner, meaning that the anodes connected together, the cathodes, one of them is over here, one of them is over here, and then you have one terminal over here. So then this becomes the base of your transistor. This becomes the collector of your transistor, and this becomes the emitter of the, not of course of the transistor, but it would be a device very similar to a transistor, meaning that a transistor is basically nothing but two PN junctions connected together in this manner. And so this would be an NPN transistor. So this would be the N material, N-type material. This would be the P-type material, and this would be the N-type material. That means that the cathode is the N-type material. I didn't know, I had forgotten this one, but then if you basically know the diagrams, then it's probably, you will never probably forget this, that if you basically do this diagram a couple of times, which is of course very necessary. You need to learn how to put these together, how to forward bias these diodes, how to reverse bias these diodes, and so on and so forth. So you need to learn how to draw this diagram without looking at anything, so from your memory, because when you want to work with it, then you have to remember the direction of these diodes. And then this transistor basically is depicted this way. So this becomes there is an arrow over here, and there is basically, then this becomes the base of your transistor, this becomes the collector of your transistor, and this becomes the emitter of, I don't know if there is 1M or 2M for emitter, 1M. If there is, this is the emitter of your transistor, right? And when the arrow is pointing outwards, that means that you have an NPN transistor. And so you can imagine that between the base and the emitter you have this diode over here, and between the base and the collector you have this diode over here. So then you know how to forward bias them, how to reverse bias them, and so on and so forth. Meaning that, for example, when you want to put this transistor in a circuit, so then if you know this, if you understand and know this, and if you know how to forward bias a diode, then you can essentially build a circuit using an NPN transistor. So basically I have this transistor over here. I can draw it this way. I can actually draw it using the diodes over here. So I can have basically this diode in this manner and this diode in this manner, and then naturally this becomes my collector, this becomes my emitter, and this becomes my base, right? Now you already know that basically you have to have base current in order to have collector current, right? And so if I were to forward bias a diode, I would take that diode. Now I forget about the meaning that basically you have this power supply. Positive is connected to anode, and negative is connected to cathode, and of course you have to have some resistor over here. This is basically a forward biased. This is a forward biased diode, and when you forward bias a diode, what that means is that current is going through the circuit, right? So since you want to have current going through the circuit, because otherwise you wouldn't have collector current, so then as a result of that you have to forward bias your base diode, which means that the anode of that diode has to be connected to the positive supply. So now imagine that I have my positive supply here, and so it makes sense that I connect this diode over here. The anode I connected to I put the resistor over here, and I connect it to the positive supply, and the negative supply of course goes to the cathode here, right? So now basically I have base current. Base current is flowing through this circuit, and this is positive and this is V of S, right? Now the problem with these two diodes is that normally if you have basically this, if you have two diodes like this connected back to back, no matter whether you put positive here, negative here, or negative here, positive here, in any case one of these diodes would be reverse biased, and basically then of course you would have no current going through your circuit. But basically what happens in a BJP, when there is base current flowing through your transistor, this part between the two diodes, if you imagine that you have, for example, you have NPN over here. So this is N material, this is P material and N material, and well, you can imagine that the P material is essentially very thin. So then once there is base current going through this transistor, then basically there is all kinds of things that happen inside the transistor, that electrons go this way and that way, and they will be attracted to the positive pole of the supply, and so on and so forth. And then as a result, long story short, collector current can flow through the transistor, which means that the current can go from here to here, which means that I can then basically connect this, that I can connect this basically this collector to positive, right? And then the emitter is already connected to negative. And in order to be able to basically control the current, the collector current, I put a resistor over here, right? And that essentially becomes an NPN transistor in a circuit, which is basically, by the way, I think it's called emitter common or something like that. But well, we will see about those circuits later. Now, if I replace this transistor with a, this is your whole transistor, I replace it with a schematic of a transistor, I would have a transistor like this, and basically your transistor, your base, as you can see, goes to the positive supply. So I can connect it to the positive supply this way, and I can put my power supply over here and connect the base to the positive supply. The negative of the supply goes to the emitter. So I connect the emitter to the negative supply, and the collector, through a resistor, I connect it to the positive supply, right? So that is basically your transistor. So this is your R of C, this is your R of B, and this is your V of S, and this is an NPN transistor. So this circuit, you need to be able to understand how it works, and you need to be able to draw it on your own, and of course you need to be able to work with it, meaning that you have to be able to take a transistor and put it, for example, in a circuit or on a breadboard, and do different types of things with it. And of course, we have already talked about all of the basic calculation that you need to know about these transistors. If you know that much, you can do basically most of the things related to transistors on your own. So this was about an NPN transistor. I'll show you how to build a circuit using a PNP transistor as well. Okay, so now basically in a PNP transistor, basically these two diodes are connected together the other way around, meaning that cathode is connected to cathode. In this case, anode is connected to anode. But in a PNP transistor, cathode is connected to cathode, and the name basically is basically based on the same thing, meaning that you have a diode over here, and you have a diode over here. So the cathode is basically connected to. The cathode is connected to another cathode over here, and then this becomes your base, and this becomes your collector, and this becomes your emitter, right? And so basically then this is P, N, and P, because cathode is N material, of course, and anode is P material, so this becomes PNP. Basically the schematic for a PNP, so this is a PNP transistor. The schematic for a PNP transistor is basically something like this. So you have basically your collector here, the arrow basically points inwards. So this becomes your base, this becomes your collector, and this becomes your emitter. And so this is a PNP transistor. Now, of course, based on the direction of these diodes, and based on the fact that you know how to basically forward bias a diode, you know how to put this in a circuit, meaning that you take the same diodes over here, the PNP transistor, that is basically you put these diodes in. If you want to use them in a circuit, you can do that by, so a forward bias diode would be basically positive negative supply. Positive through a resistor goes to anode, and then the cathode is connected to negative. So that means that the cathode, if I give it to the negative supply, and so since this is my base, I have to put the resistor over here, give this to, connect this to the negative supply, and so this would be the negative supply, and the positive supply has to be connected to this anode over here, right? So now, as you can see, this diode is forward biased, and so your base current is flowing. And since the base current is flowing, collector current is also flowing as well. And so basically then this essentially becomes your base, this becomes your collector, and this becomes your emitter. And then collector has to go to the ground as well, to the negative as well. So this is basically how you draw a PNP transistor. So let me see if I haven't made any mistakes here. So that is basically your transistor. And then if I were to, so basically what we do for basically this part, I can substitute it with an actual schematic of a PNP. This is a PNP transistor. I can draw a PNP transistor like this, and the arrow is pointing inwards. The arrow is pointing inwards. The base goes through a resistor, goes to the negative supply. This goes to the negative supply. The positive supply goes to the emitter, and then the collector through a resistor goes to the negative supply. So that basically becomes something like this. And so basically we can actually put you can use two power supplies, or you can use one power supply. It's NPN. That's basically how you connect a PNP transistor to a power supply. This is R of C, and this is R of B, and this is a PNP transistor, right? Okay, so that is basically the schematic of a the schematic of PNP and PN transistors, and based on the diodes and the forward bias and so on and so forth. Now in the next video we will talk a little bit about a couple of problems related to these BJP transistor. I'll see you in the next video, and thank you.